Welcome to the next session, my dear friends. In the previous session, we are discussing about the lapse rate. We have discussed super adiabatic lapse rate and sub adiabatic lapse rate. Now we are continuing this in this topic. Now, actually, lapse rate is nothing but what is the change in the temperature in the environment, and also what is the change in the temperature in the pollution parcel. So that is nothing but the lapse rate. That is nothing but the lapse rate. Okay. So the lapse rate will decide whether the pollutant disperse in the atmosphere or not. It decides the pollution parcel movement. So that in that we have discussed super adiabatic and subadiabatic. Now the third one is neutral adiabatic lapse rate. That is when ELR is equal to ALR. When ELR is equal to ALR. So in this also pollution disperses. Okay. So the dispersion and disposal of pollutant is possible, but not that as fast as the super adiabatic condition. See, in super adiabatic condition there is a problem also. Because when ELR, whenever we see the pollution parcel is cooler. Okay. So when the pollution parcel is cooler, then for example, at a particular elevation, let us say this is 0. Okay. Or let us say this is 10 kilometer height. So at this height, not 10 kilometer, let us assume that this is 1 kilometer height. Here I am disposing the pollutant into the nature. Now here the pollutant is not warmer as that the environment is. So the environmental temperature TE is greater than this TP pollution parcels temperature. Okay. Now here ELR is greater than ALR, right? So this is called super adiabatic condition. ELR is greater than ALR. Now in this case what happens? The pollution parcel will move down. So at the exit point, this is the exit point. Okay, this is the exit point. At the exit point, environment temperature is more than the pollution parcel. Then the pollution parcel will go down. So here ELR is more. In the reverse direction also ELR will be more, but in this direction what happens? Temperature increases. Lapse means difference, so temperature increases in the downward direction. Now at some 0.9 kilometer, so the lapse in the TE is more, so TE 1, so the lapse is more means the temperature increase will be higher here. The temperature increase will be lesser here. So that means at this elevation also TE1 is greater than TP1. So TP1 further moves down. So are you getting the point? So though in the super adiabatic condition also the pollution parcel, if the pollution parcel's temperature at the exit point where we are leaving that from the stack into the environment, at that elevation, if environment is warmer, then it continuously comes down, though it is a super adiabatic process. But in reality, always due to the reactions and all, whatever the pollutant smoke that comes out of these chimneys are always warmer only than the natural environment. But this is also a condition which is possible. So during midnight or during peak summer afternoon, the temperature of environment may be very high. So if at that point of time, if you are leaving this parcel, so that is generally the industries works during night, because always this temperature will be lesser, the environmental temperature will be lesser, and the pollution parcel's temperature will be higher. so that it can safely escape the environment. So in super adiabatic condition also, the one condition is there in which the pollutant parcel may come down. Okay, that condition is nothing but when at the exit point the temperature of the environment is more than the temperature of the pollution parcel. In this case, though it is super adiabatic process, the pollution parcel will not rise up, it will come down. So this is again a problem associated with super adiabatic lapse rate. So that is why in the neutral adiabatic lapse rate, so this is called considered as ideal lapse rate. So this is considered as ideal lapse rate because the pollution parcel moves uniformly upward. Okay, ideal condition. This is ideal condition where both will match. So ELR and ALR. Okay. So next is negative lapse rate. Negative lapse rate. So negative lapse rate means, so generally environment should have to lose the temperature when it is moving up. Environment has to lose the temperature when it is moving up. But if it is gaining temperature, generally this happens during midnights of winter season. So where the temperature at the earth surface will be very less, and gradually the temperature rises when it is the environment, when you are moving up in the environment. So that means negative lapse rate means environmental. Always adiabatic lapse rate is same. Adiabatic lapse rate will be always reducing. This is ALR. It is constant, that is 9.8 degrees centigrade per kilometer. So that is constant. But ELR, so here ELR is increasing. So the temperature of ELR, so that means the pollution parcel never move up. It continuously comes down. Okay, it completely comes down when in this case of negative lapse rate. In this negative lapse rate, so what happened, we call this condition as inversion. We call this condition as inversion. So when the temperature is gaining, when temperature of the environment is increasing, okay, so then what happens? The pollutant parcel will come down. It is the worst condition. It is the worst condition for disposal of pollutant, and the environment is highly stable. So it is highly stable condition which we don't want. So this is a highly stable condition which we don't want. Okay, so that is why generally when there is inversion, so it is better not to release the flumes through the stacks. Okay, so depending on that we need to design the stacks. So this is inversion. Likewise, there are many conditions. Actually, these are the some of the conditions. So there are many conditions that are possible in the ELR. So ALR is always same. It constantly reduces. But ELR can change from height to height, with altitude. Daily it will change, seasonally it will change, during day, during night. So there are many combinations that are possible in the environment lapse rate. Depending on that, the plume rise models, we call them as plume rise models. That means plume means nothing but the smoke which is coming out of the stack. The plume rise, how it is rising. So how it is rising out of the stack, that is in the way pattern of that rise, that is called a model. So how these plumes are coming out of the stack and how they are moving in the environment depending upon the conditions of the environmental lapse rate and also wind flow, pressure present outside, because there are many factors that affects these plume rise models. So not only the temperature always affects the pollution disposal, but majorly temperature is a prime important factor which decides the propagation, disposal of these effluents, disposal of these pollutants. But along with that, some temporary factors like wind is nothing but what? Wind is nothing but disturbance in the environment. So when the air is flowing with some pressure, with some force, with some speed, that is nothing but wind. So the wind also changes the direction of the dispersion of the pollutant. So wind direction and wind speed, so both will affect the dispersion of these pollutants. Along with that, the pressure outside. So sometimes the pressure may be same, but during the depression, cyclonic depressions and all, the low pressure condition may prevail or high pressure condition may prevail, because of which the pollutant dispersion also varies. So all these factors are temporary factors, though they affect the dispersion of the pollutants. Also moisture in the atmosphere also affects the dispersion of this pollutant, as well as formation of the other pollutants too. So wind speed. So before going into the plume rise models, so wind speed also. So what are the other factors? So what are the other factors that affects the plume rise? So along with the temperature, so there are some other factors which affects the plume rise. So wind speed and direction. So generally wind speed we measure using 1/7th power law. And the equipment which we use is anemometer. So this is the equipment which we use to find the wind speed, and once we find the wind speed at some level, so for example at some level of Z0, okay, let us assume that the wind speed is V0 at some level Z1. So what is at some level Z, what is the wind speed V? If you want, then V by V0 is equal to Z by Z0 whole to the power of 1/7. So we can find wind speed. Generally the wind speed at the surface of the earth will be taken as 0. It is like a boundary layer. So wind is also a fluid medium. So generally the wind speed, if you see, so at the earth surface, this is the earth surface, if you take here, it will be 0. It gradually increases and reaches to some value, maximum value at some height, altitude. So this change, so the increase of this wind speed depends on 1/7th power law using this equation. So at some altitude, if you know V0, so let us assume this is Z0. At any altitude you can find the V value. Okay, at any altitude you can find the V value using this 1/7th power law. And also wind direction. So in which direction the wind is blowing, that also decides the movement of the pollutant. In that direction only the pollutant will move. So wind direction also important. So the wind direction generally we find using wind vanes. If you might observe these wind vanes in many locations, in runways also we see these wind vanes, so which shows the wind direction. Okay, so accordingly the temperature, wind speed and wind direction, all these factors will decide the plume model, okay, plume rise model. And apart from this wind speed, pressure also plays a major role. What is the pressure outside? Because we are releasing it with an atmospheric pressure, we are releasing it into the nature, so with some temperature and pressure. Once it enters the nature environment, so it has to blow with a pressure of atmospheric pressure only, okay. So pressure. So generally the pressure will be 1 atmospheric pressure only when the environment is stable. But during cyclones, anticyclones, during those time, the pressure, what happens? The pressure will change. So during cyclone, what happens? Cyclone is nothing but a low depression, low pressure zone that is created in the sea. So which that is low pressure zone. So we are in high pressure zone. So what happens? All the wind will flow towards the low pressure zone. Okay, so that means, so the pollutant will go in the direction of the sea. In the direction of the sea, that means it is coming down. So during cyclonic pressure, what happens? So it will create a highly unstable environment, atmospheric condition, so in which the pollutant will disperse. Okay, disperse. Whereas in anticyclone generally it is in high pressure. So high pressure is present outside, low pressure is present on the land mass. So here the disposal of the pollutant may not be possible during the anticyclone condition. So that is why we consider the anticyclone as stable condition, anticyclone as a stable condition, whereas cyclone is unstable condition. So but these things will appear only during the pressure change is there. Otherwise we don't consider them, because outside the atmosphere will be or 1 atmospheric pressure only. So these things affects the, and also humidity also affects. So the humidity also affects the plume rise, because when there is a humidity, the moisture is present inside the environment. Okay, the moisture is present inside the environment. So whenever the moisture is present, and photochemical oxidation will be possible. If you see the previous lectures, in that photochemical oxidation, in that water also plays a major role. So we have seen that. So that is why when moisture is present inside the environment, then photochemical oxidation and these reactions will take place. So causes some secondary pollutants. So they causes some secondary pollutants, and the disposal will get affected by those secondary pollutants. So when there is a humidity also present, then the plume rise may vary depending upon the degree of humidity present inside the environment where we are releasing this smoke and the plume. Okay, so these are the different factors which affects the plume rise other than the temperature itself. Okay, so now what are the different kinds of plume rise depending upon the ELR? So we assume that the wind direction is constantly blowing in the same direction. So we assume that for all the figures, I am assuming the wind blowing in this direction. Okay, so for all the plume rise models, I am assuming the wind is blowing in this direction. Okay, now the condition and corresponding plume which is possible there. So condition plume rise models. So this is altitude. altitude and temperature. So first one is ELR is greater than ALR. ELR is greater than ALR. Then looping plume will come. Looping plume. So the looping plume will be like this. It will be, this is called a looping plume. It's called looping plume. And ELR is less than ALR. This is ELR. ELR is less than ALR. Then the plume rise model will be coning plume. So it looks like a cone, that is called coning plume. Next is inversion. This is ALR, this is ELR. This is called inversion. This is called fanning plume. So during inversion, so everywhere it is altitude and this is temperature. So this is the third case where we got fanning plume, where ALR, ELR both are changing like that. And ELR is inversion, first of all inversion, and then it is reducing. So this is ELR. So here lofting plume. So this is called lofting plume. So lofting plume will be appearing when ELR is inversion for some height, it is inversion and then it is decreasing. And next, so this is ELR. So it is reducing. So it is in superadiabatic condition and then it is entered into inversion. So in this case, fumigating plume. Fumigating. So the plume will rise and then it will come down. This is called fumigating. This is called fumigating plume. Okay. So next one is trapping plume. So here it is favorable condition. So the disposal takes place. But here after at this height So here it is inversion. So here the disposal cannot be taking place. So here it is trapped in this layer. Actually, scale to be precise, if I lift it, so up to this height dispersion takes place. After that it will trap. It will trap inside this layer. Okay, in this layer. So this will get trapped. It's a trapping plume. Trapping plume. So these are the different kinds of plumes depending on the change in the environmental lapse rate. If you look at ALR, everywhere ALR is same, but the only concept here is, so when there is superadiabatic condition, the plume will rise. When there is any other condition prevailing, then it will come down again. Depending on that, we have drawn these plume rise models. Okay, so depending on these things, we fix the stack height. Okay, we fix the height of the stack. So design of the stack is also needed. So what is the height? What is the height of the stack we need to keep? So the height of the stack depends on all these factors which we have discussed so far: temperature, pressure prevailing there, the wind speed there. So all those things and the type of area. So all these factors we will consider to fix up the height of the stack. So the design height of the stack. So if you know the plume rise delta H, okay, so with that we can decide the stack of the height of the stack. Okay, so we use a Holland formula to determine the rise of plume, to determine the rise of the plume. We use Holland formula. We use formula where delta H, let us see, assume that the rise of the plume is delta H. So the delta H is equal to Vs d by u, Vs d by u into 1.5 into 2 plus 2.68 into 10 to the power of minus 3, 2.68 into 10 to the power of minus 3 into dt by Pd into delta T by Ts. Delta T by Ts. So Vs is velocity of gas in the stack. And P is the pressure. Generally atmospheric pressure we take, pressure in the atmosphere. So we take it as 1 atmospheric pressure if the pressure outside is atmospheric pressure, but we take it in millibars. Okay, velocity of stack, and d is the diameter of the stack. Delta T is stack gas temperature minus atmospheric temperature. Ts minus Ta in degrees Kelvin. In Ts is stack gas, whatever the gas coming out of the stack gas temperature in degrees Kelvin atmospheric temperature in degrees Kelvin. So using this we can find the plume rise height. Okay, so the height of the stack, actually what is the height of the stack? Height of the stack, generally we provide this. Let us assume this is the height of the stack. Okay, and this is the plume rise height. So before dispersion, what is the height it is rising? That is nothing but plume rise. Okay, before dispersion, so whatever the plume that it is transferring into, it is a fumigating, coning, fanning, fumigating, whatever it may be. So up to that rise, vertical height, vertical movement of this plume is called rise. So we consider this as a physical height of the stack. Physical height of stack. So we consider if h is the height of the stack, if h is the height of the stack, and so this is the total height of the stack. We consider this as the total height of the stack. So this is the physical, where h is the physical height of the stack. This is physical height of the stack. So the h is physical height of the stack, and this is the total height of the stack. So h plus delta h, we take it as total height of the stack. So this is all about the plume rise and plume height, finding the rise of the plume. Okay, finding the rise of the plume. Now here one more thing that is important is the plume is nothing but the smoke. The plume is nothing but the smoke which is entering into the nature or environment. See, there are two kinds of pollutants that enter into the environment. In total air pollution, if you see, total pollutants can be categorized in two ways only. One is particulate form, so the form of pollutant. The form of pollutant, either it may be in particulate form, or the form of pollutant may be in the form of a smoke or gas. So here whatever the pollutant that is entering from the stack majorly is in the form of smoke. Okay, majorly in the form of smoke only. So we don't find any kind of particulate matter here, until unless if there is any incomplete combustion, then some kind of carbon matter may come in the form of small particulates, but majorly smoke will come out of the stack because that particulate matter cannot travel that height. So generally, so smoke only comes out of this stack. So here, to find the properties of the smoke, that means the density of the smoke. So the property of the smoke is nothing but density of the smoke. So the density of the smoke is determined using Ringelmann chart. Smoke is determined so we use Ringelmann's chart to find the density of the smoke, and this smoke we take the sampling, whatever the sampling we do, that sampling we call it as isokinetic sampling, means the smoke is moving. So it is not a stationary object, it is a moving object. So we will take the smoke from different locations of the stack. That kind of sampling is called isokinetic. So we call that as isokinetic sampling. So we do isokinetic sampling to collect smoke sample. To collect the smoke sample. So this is all about the plume and its properties and its rise models, okay, and its height. Now, controlling of air pollution. So far we have discussed what are the pollutants. So what are the major air pollutants, what are primary air pollutants, what are secondary air pollutants, how they are entering into the air, and all these things we have seen, and how to control them, See, I have already told you many times during the discussion of the air pollution, simply dispersion of air pollutant is not considered as the pollutant is removed from the system. So the pollutant is still there. So we cannot remove the pollutant from the air once it entered into the air. Okay. So here generally the controlling measures. So the controlling measures majorly we prefer preventive measures. So the controlling can be done at source, that is called preventive measures. Preventive measures. So before doing pollution, we need to think twice. How can we prevent it? And we can remove it by using some kind of controlling equipments. So, or we can control it by installing the controlling equipments. So, what are the preventive measures? If you see thermal power, when we are using thermal power, we need coal combustion. So, when coal is consumed or combusted, so SOx will emit into the environment. So, what we can do? So, we have to reduce the thermal power usage and rely more on renewable sources such as solar power. So that is a preventive measure. So if we reduce the coal combustion, so we can reduce the SOx emission. Are you getting the point? So likewise, so if you are using some nitrogen plants, so where we are generating some kind of nitrogen compounds, so there if you reduce that production, we can reduce the emission of NOx into the environment. Or else, so diesel consumption will emit hydrocarbons, carbon monoxide into the nature. So if you reduce it, we can reduce the emission of these pollutants into the nature. So if you rely on electric bikes, so electric cars or solar driven cars, so these things may reduce. So whatever the things I am discussing is, so what is the alternative source which is eco-friendly? So these days we call greenhouses. So how to construct a greenhouse? So that means where the emission of the greenhouse gases is very much restricted. So completely it is dependent on solar energy. So greenhouse concepts and all. So which are all the thoughts, it is not single thought. There are various thoughts we can put together to save the environment. So that is called preventive measures. These are the preventive steps. Okay. So in that preventive steps, many things we can do. So we can change. So this is also called the source corrective or source correction. So one point is, so changing the raw materials which we use, changing the so if you know or don't know, I don't know, 1 kg of cement manufacturing will evolve 1 kg of CO2. So 1 kg of cement manufacturing process will evolve 1 kg CO2 into the environment. So if you reduce that cement usage by using supplementary cementitious such as fly ash, GGBFS, and also these days we have invented, so without cement also we can construct, we can gain the strength using geopolymer concrete. Without cement, we can achieve a strength of M25. That is nothing but change of raw materials and change of manufacturing process. Okay, change of manufacturing process. So many industries rely on energy. So heat is needed. Whatever it may be steel plants, it may be oil refineries, it may be anything. Everything needs heat. So that heat can be produced either by combustion of coal or by other ways also. So renewable energy also we can use to give heat energy. So we need to think of how to generate that heat without evolving the pollutants into the nature. So that is how we can change the manufacturing process. And also usage of tall stacks. Again, this is just to dispose, not to completely eradicate the pollution. Using tall stacks. Using tall stacks. And also using of tall stacks, and so we need to separate these industries. So during the planning, town planning and all, so these industrial zones should be kept far away from the residential zone, such that so these pollutants can be collected separately and treated separately. So that is again a preventive measure at source. So that is called zoning and planning. And strict law should be enforced. So law enforcement. So if they have deviated from any of the pollution control, whatever the pollution control department, whatever the guidelines that are specified, if they are not following those guidelines, they should be strictly punished. So that kind of law enforcement will also prevent somehow the air pollution. Okay, see these are qualitative, not in form of quantitative. So these are all the qualitative methods. These are all behavioral changes which we need to make. And this is another thing, that is control techniques. So control techniques using some equipments. So I told you already, so there are two kinds of pollutant that will present in the nature. One is particulates, in the form of particulates or in the form of smoke or gas. So or gaseous pollutants. So we have to treat particulates in a different manner and smoke in a different manner. So if they are particulates, we use different kinds of equipment such as gravity settling chambers, centrifugal separators, gravity settling chamber, centrifugal separators, gravity settling chamber, centrifugal separators, electrostatic precipitators and fabric filters. So these are the different kinds of equipments that are present to take care about the particulates matter. So gaseous controlling equipments, gaseous pollutant controlling equipments, they are absorption. They generally, the different equipments, they work on three principles. One is absorption principle, and other one will work on adsorption principle, and some work on combustion, incineration principle. Because the smoke, generally the smoke comes because of incomplete combustion of carbon matter. So whenever the smoke is coming, if you burn the wood, if heat is not present, smoke will come. If you observe that, so wood combustion, we all witness this. So when the wood is burning, suddenly if whatever the fire stops, then smoke comes. So the burning process is going on, but the smoke is coming. So that means incomplete burning of any kind of carbon matter causes the smoke. So the smoke will have some energy of combustion. So that we do, by doing incineration, we completely burn it so that the pollutant can be completely converted into the form of ash and we can remove it. Okay, so these are the different techniques which we use. The gravity settling chambers, generally it is a kind of a settling tank. Simply we can say it is a kind of settling tank only, but in this, whatever the pollutant gas, so pollutant air or gas, we enter. So from this plume directly we will send it into the gravity settling chamber, and so with some spray, so gravity settling can be done naturally also. If you look at the rainfall happens, so the rainfall will take all the particulates present into the nature and bring it down onto the earth surface. Similarly, here in gravity settling chamber there will be a spray, so which sprays the water, so that increases the weight of these particulate matter which will come down and collected at the bottom of the tank. So generally it works on the principle of Stokes law only. So the diameter of the removal, the same Stokes law formula can also be used here in gravity settling chamber. So centrifugal separator works on the principle of centrifugation. So the wind, the speed, so we create pressure, so high pressure zone at the center, so because of which the wind will go out of this filter paper, so it leaves that dust particles present inside and the wind will go out. So that is centrifugal separators. Electrostatic precipitators, actually these are all particulate matters, are very fine material, so they contain charge. We already discussed this in water supply engineering. So the finer materials will carry charges, surface charges. So we send this particulates into the electric zone. So electric zone, there the particulates will go and stick to the corresponding opposite charges. So these are called electrostatic precipitators, which remove the particulate matter very effectively. So we discuss little bit more about the electrostatic precipitators because these are the equipments which we use in thermal power plants and steel plants because to remove the particulates. That is why we will discuss little bit. So how to find the efficiency and all of these electrostatic precipitators, little important for the gate examination. And fabric filters are also, a fabric will be present. So heavy wind will move through this fabric filter. So the wind will move outside the fabric filter, but the pollutant, whatever the particulates, cannot pass through that permeable membrane. So there they will be removed from the pollutant, from the air. So these are the different techniques to remove the particulates. Absorption, adsorption, incineration. So absorption, so here all these things, so we will send the pollutant into a chamber. So into a chamber we will send, so a chamber, any chamber you take, so we will send the pollutant into a chamber. So here we will feed it with some chemicals. So we will feed with some chemicals. So the chemicals will absorb. So whatever the gas that is coming, so here absorption takes place, and after absorption, so the whatever the chemicals will absorb the pollutant, gaseous pollutant, and leave the pure air outside. So the air free from pollutant will come outside. Okay, so the whatever the chemical reactions takes place, that absorbs the pollutant and removed outside. So whatever the pollution precipitate, that will be taken out like this. And adsorption, So we will send the same into a medium. Here a medium like activated carbon, which we discuss. Activated carbon is good adsorbent. So but not here we use activated carbon, we use different kind of material which adsorbs, not absorbs, adsorb the gaseous pollutant and leave the fresh pure air outside. So that is called adsorption. So incineration means we will send this gaseous pollutant, along with that we will give some fuel. So we will send some fuel into it, into that chamber. So here this fuel and these pollutants, the gas containing pollutants, will completely combustion will be done. So the pollutant will be removed. The pollutant will be removed due to the combustion. Okay, so this is for this class. So we will discuss the electrostatic precipitators efficiency in the next class, and also we will discuss the noise pollution there. So after completing the noise pollution, so we are done with the theory part of the air pollution and noise pollution. We will be doing the questions, and by that we have completed the whole syllabus. Thank you so much.